All right, so let's see what you got there. It says determine the first three iterations, which again then means x1, x2, and x3. And of the three notations, I truly believe this is the easiest one because all you basically have to do is take the initial value, substitute it in, and what do we get for our x1? 6, and then you put 6 in, and we get, then you put 4 in, you get, is it okay to get 0? Yeah, that's fine. If you happen to put 0 in, you would get -8. Is it okay to get negative terms? Yes. Then realize on something like this, if I were to ask you, say, to find the first 5 terms and find the sum can actually end up negative. So keep that in mind. That can definitely happen. It hasn't really up until now for us, but it could. Again, if I just asked you to find the sum of the first 3, you'd tell me 10. Pretty simple. Okay. Any questions? All right. This one here can be a tricky notation. It's very similar to the first one, but slightly different. It's kind of a combination of the first two we looked at. This last one back here gave us a function like 2x minus 8, and then the beginning one just kind of gave us a general formula of how to do it. Well, this is a combination of the two. It kind of gives us the function, but not really. Because do you see f of x equals anything? No, you don't. But I do know that if I put 0 into that mystery function that's out there somewhere, I know that I would get 2. And that's about all I know other than that formula that's going to tell me how to get from term to term. The nice thing about 0 when it's in this one is it actually counts. F of 0 counts as a term. When it's in this format, whatever the lowest value they give you, f of 0, f of 1, whatever the lowest one is the one that's your first term. So for right here, f of 0 is 2. Again, remember what that means is they put 0 into some function, and they got 2 as an end result when they did the math. We don't even know what it is, but we know that's what they got. And here it says the first 4 terms. Well, then I better find f of, because if f of 0 is the first one, I better find f of 1, f of 2, and f of 3 is what we're looking for. So now you're going to see how this is very similar to the first bunch. To have it say, I need to find f of 1. So basically, I got to make sure this says f of 1. And what's the only n value that's going to allow that to happen? So yeah, 0. So like I said, why don't you make a note of that just so you don't get confused as you're going through the problem? And this is another case where you're probably going to see a pattern pretty quick, and then you can use the pattern. So now you substitute it, and it'd be f of 1 equals 4 times f of, now it says f of n. And what is n? That's why you make the note so you don't forget. It is 0. And then we're supposed to subtract 1. Any questions on how I substituted that information in at this point? Because we chose n to be 0, because if that right there is 0, it'd be f of 1 is what it would say. And that's what I need to find. But that's also why we make the note so we don't try and put f of 1, say, right in there, because that's not what I want to write there. Okay, that's why I make a note. Okay, so f of 1 is 4 times whatever f of 0 is. I sure hope we know what it is. And we do. We were told it's 2. And then minus 1. So f of 1 ends up being 7. Because f of 0 is 2. So I replaced it. So Tabitha, I need this right here to say what if I'm looking for f of 2? I need it to say f of 2. So what does n have to be to make that happen? N has to be 1, exactly. Because if I put 1 right there, it's going to say f of 2. So there we go, n has to be 1 in this case. So it's 4 times f of whatever n is. And n, we found out, is 1 to make this happen. But it's only going to work if we know what f of 1 is. How do we know that? We just figured it out, exactly. So f of 2 is 4 times f of 1, which is 7 from just a second ago, minus 1. So f of 2, I've been told, is 27. I agree with that. The question was, is it a coincidence that it goes 2, 7, 27? And yes, it is. Very much a coincidence, yes. Because the next term is not going to be 2,727. Okay? But basically, here's where I like to show another method is what is this really asking me to do? Well, what it's asking me to do is take the, say, previous term, take it times 4, and subtract 1 is what it's asking me to do. Take the term before it, times 4, minus 1. So can you do this a little quicker now if you see the pattern? Yes, you can. That's the two ways you could look at it. So let's take this. To find f of 3, let's take 27 times 4, like it says to do, and then subtract 1. That looks like 127 now. There we go. So if you take 27 times 4 and subtract 1, 107. So are there any questions as to how that one worked out? It's all notation is what it really boils down to. But the part that I don't think is quite impressive enough for you is that they're giving me all these values and they don't even show me the function. There's some function out there that when I substitute in 0, I get 2. When I substitute in 1, I get 7. 2, I get 27. 3, I get 107. And we don't even know what the function is. Any questions? Well, this is a big one. If you can do example 5, I think you've got this one figured out. Now remember what I told you though, f of the lowest number they give you is always the first term. So it's f of 0 in this case is going to be your first term. So f of 0 is 1, f of 1 is 3. The little formula for you is right here to try and find the other terms. It does ask for the first 5, but you've already been given the first 2. That means take 2 times f of n minus 1 is what that means. Yep. All right, sounded like a lot of good theories out there as you were trying this one. The reason I told you if you could get this one, you'd be all right, is this one does actually work a little bit different. Instead of using the previous term, it actually makes you go back 2 terms to get the next term, which is why this one's a little bit more complicated. But if you follow my patterns I gave you, it still works pretty good. So f of 0 we know is 1, well, because they told us. And f of 1 is 3, because we were told. And it said first 5, so all right, we'll say we got to find f of 2, f of 3, and f of 4. So f of 2 is the first one I don't know. So again, you got to go up here, and I have to make that right there say f of 2. And there's only one way to make that happen, and that's if n is 1. So as you're going through this formula, anytime you see an n, you're going to put 1. So if I go right here, I make that a 1, it makes it f of 2, which is what I wanted it to say. So then there's a 2. And then f of, well, if you put a 1 there, it makes it f of 0 plus 3. I think some of you were thinking that as just 0. And so you took 2 times 0 plus 3, but it's saying f of 0. Now f of 0 could be 0, but f of 0 is actually 1. It says so right here. And so that is 2 times 1 plus 3. So that's what f of 2 is going to equal. And it's 5. Okay, so really you notice to find f of 2, you had to go all the way back to f of 0 to figure it out. That's what I mean. You had to go back 2 terms this time to figure out the next one. So f of 3, sorry about that, that's not quite in there. What would n have to be here? Again, you're going back to this box I got here. N has to be 2. So it's f of 3 equals 2 times, now again, you're going to put 2 right there. So it becomes f of, I don't know why I put so many parentheses there, but I did. And then plus 3. So to find f of 3, it's 2 times whatever f of 1 happens to be, which thankfully they told us it is 3. If you look up here, f of 1 is 3. Plus 3, so we're talking about 9. Once again, that pattern, you know, there is a pattern there, but it might not be as easy to see. Okay, because kind of it goes up by 2, then up by 2, then up by 4. You know, so it's not arithmetic, not geometric. So in essence, to find this term, again, this is for those of you that like to find the pattern, I'm going to go back 2 terms. So we're going to go back to the 5. I'm going to take it times 2, which is 10, and then I'm going to add 3 to it, which is 13. Again, that completely depends on how you see those formulas. Some people see them very well. Some people think they're a little weird. Okay? Are there any questions? Okay. You have a worksheet today, and then on the back of the worksheet, I'm going to have you write down a sequence, a very famous sequence, and perhaps the most famous sequence. It has a very specific name. If you can get me the name of it, I'll give you extra credit. If you can tell me the pattern, just writing down the pattern, I'll give you extra credit. If you can write the pattern in something like this, I'll give you even more extra credit. The sequence is. You can write this on the back of your worksheet, it's probably the best place. Yeah, because you'll probably look it up on the internet, so spelling should probably count. Again, the ellipsis means that keeps going. So there's a shot for extra credit. Does everybody have it written down?